So, I am Dr. D. Sarala. Let us now discuss about the signals and systems. Before we talk about signals, let us see what a signal consists of. A signal consists of information and data. That means when a signal is being transmitted, it transmits information, along with it data also is being sent. So now let us consider different type of signals that we talk about. We have here telephone and music. They correspond to the video signals and the audio signals, and both of them are functions of time. So when electrical charge is distributed in space, we say it is a charge density. So there it is a function of space. Earlier we discussed they are functions of time, and electrical charge is considered to be of space. So when a signal is divided into audio and video signals, let us talk about the system. What is a system? A system is something which is used to process the signals. That means it is used to modify or extract the information from the signals. For example, radar signal. Radar is one which is expected to navigate, is expected to record the movement of these signals. For example, if you take a missile launcher and it is tracking a target which is in motion, that means it is a moving target, then what is the information required here? The information that we are processing here is its location. So if you know its present location, knowing present location is the information. If this information is given to you, its future information can be determined. So this is inferring some information from this. That means you are processing something on the given signal and trying to extract something more. So that is what is being done by system. Signal is one which is being carried. System is the one which actually processes the given signal. So in this case, since past location and velocity is known, by properly processing this radar signal, the future position may be estimated. So there is a clear distinction between the system and the signal. Signal is the one which is carrying the information. System is the one which processes the given signal and gives the desired results. So now let us consider the different type of signals. The signals that we are considering are of different types. They are continuous time and discrete time signals, analog and digital signals, periodic and aperiodic signals, energy and power signals, deterministic and probabilistic signals. What are they? We are talking about continuous time and discrete time signals. What are continuous time? That means it's like audio signal or a video signal which is continuous in nature. How do you represent this graphically? You take time on the x-axis, all these recordings, music, speech, etc. on the y-axis, and it becomes a continuously variable signal. Next, discrete time signal. Discrete time signal refers to, you can see on the x-axis there is a time, on the y-axis it's amplitude that is being plotted. This is specified only at discrete points. T is equal to nt. The data is collected at specified intervals of time. As you can see, at some points it is low, some points it's high, low, high, and so on. So these are known as your discrete signals. Next you have analog and digital signals. What are analog and digital signals? Analog and digital signals. Amplitude can take on any value. As you can see, it is starting as time is progressing from the negative to the positive axis. It can take any value. It is a variable parameter. The amplitude is varying. It is varying over a continuous range. Therefore, it is analog, and also it is continuous. Next, in the same way, we also have, in this case, a discrete one. And you represent it as a digital and a continuous signal. So it's digital because you are representing it by a square wave, on, off, but it is continuous. That is the difference. Next, analog and discrete. You can have analog and discrete. See, analog signal because it's a continuously varying. And why do you call this as discrete? Though it is continuously varying, it is occupying discrete values at different instances of time. So this is analog as well as discrete. Then you have digital and discrete. What is digital and discrete? This is analog and discrete. This is digital and discrete. Digital and discrete means discrete because at different intervals of time it is taking different values discretely. Digital because between, let us consider this interval of time between these two. So it is high here, it is high here. In between it is just 0. In this interval, at this point this is high, at this point this is high. Between these two intervals, what's happening? In between these two intervals, there is actually the signal is almost zero. This is what it means. So this is how you define discrete and analog discrete intervals. So continuous and discrete. How do you differentiate? Nature of the signal along time axis, then it is referred to as continuous and discrete. Then if it is analog and digital means signal's amplitude. That means when you are talking about analog signal, you consider the amplitude. When you talk about this kind of continuous discrete, it is along the x-axis, that is the time. So is it the time that you are measuring, or is it the amplitude that you are measuring? That is what determines which signal, which type of signal is what you are considering. Now we have periodic and aperiodic signals. What is periodic and aperiodic signals? If g of t, if the given function is equal to g of t plus t naught for all values of t, it implies that it is a periodic function. That means it is repeating itself after every time interval of t0, which is referred to as the time period. So examples are this. This is the time period, it is repeating itself. You consider this example in this case, wave is having different patterns at different instances of time. So we say it is a periodic signal. Definition: a signal g of t is periodic if it remains unchanged after one period. So it must start at t tending to minus infinity and continue to plus infinity. That means it's forever. So we can say g of t is equal to g of t plus t naught, which is equal to g of t plus 2t naught, etc. up to g of t plus mt naught, where m is any integer. These are all the things. Then we have energy and power signals. Signal with finite energy is energy. Signal having finite power is a power signal. So when you say the average value, this, when you write this g of t modular sign and square, and you integrate between the intervals minus infinity to plus infinity, what we are calculating is the average value of this energy signal. So if 0 is less than limit of this interval, within that interval, the time period being 2, that means it's minus t by 2 to plus t by 2 as t tends to infinity. Limit of this integral value lies between 0 and infinity. It implies that it is having power, and we call this as power signal. A signal that is observed in nature, every signal which is observed in nature is an energy signal. So once it has energy, it also has power. Next we have deterministic and random signals. That means they are only approximations. What are they? Probabilistic or mean square or distributions. A signal whose function or whose information is known completely is deterministic. That can be represented either graphically or mathematically. Whereas random signals are only approximations, they can be only probabilistic, it can be represented as mean square or distributions. That means probability of finding the signal is here, probability of signal not finding is here. That kind of an information is what is being carried for random signals. For deterministic signals, you are sure of its position, its location. Therefore, it is deterministic. We will see these examples later in the next lecture. So, next you have unit and impulse signals. A unit, as the name indicates, it has amplitude of 1. It is also known as a Dirac function. Delta t is equal to 0 when t is not equal to 0. That means every other place of t it is 0 except when t is equal to 0, where it takes a value which is equal to unity. So when you integrate this signal between the limits minus infinity to plus infinity, it attains a value of unity. Therefore, it is an impulse function because it shoots up at time t is equal to 0. Rest of the time it is 0. Hence, it is also known as impulse function, or also known as delta function. Properties of this delta function. What is the property? The width of the pulse is very small and height is very large because it is tending to a very high value there, and it is represented by this. It's between the two in time intervals between minus epsilon by 2, 0 and epsilon by 2. So the height is very large, and it's given by the expression 1 over epsilon naught, and as epsilon naught tends to 0, it attains a maximum value. It's basically a rectangular pulse with the width that becomes infinitesimally small. The height is infinitesimally large. The area is unity, and as we have already seen, delta t is equal to 0 everywhere except at time t is equal to 0. What are its properties? Multiplication of a function by an impulse. Let the function be represented by phi of t, and delta t tends to 0 and delta t tends to high at time t is equal to 0. So when you multiply this delta function with the scalar function, what you are getting is phi of 0 into delta t. This is at time t is equal to 0. Then this can be written as phi of t delta t minus t is equal to phi of t into delta t minus t. That means it is displaced from its value at t to a t. Impulse pulse is located at t is equal to t. So if phi of t is defined at t is equal to t, this is how you will be writing it. So this is how it is calculated.